Hi everyone, I am Bentic Sebastian. I worked under Professor Guy Garnett in the eDream research group. My graduate mentor was Liu Yishio, and the problem I wanted to solve was how to create a simulation based that could be controlled by hand gestures. So here's a model of the quadcopters I made in Unity, if you can see that. I don't know if yeah, so right here. So the idea was to transfer data from a software called Max uh, and transfer position data and then use that position data to create 3D objects. That was the basic idea. So as you can see, maybe it's too small, but that's the framework. So we receive information about joint data from our Kinect, and then we run the data through Max, and we generate, we use an algorithm called the Boyd's algorithm, if anybody's familiar with that. We use that algorithm to generate positions of about hundreds of a flock of particles. We call it flock. So once we have that, we send the position data to Unity, where we transfer that data to like these 3D objects. Now, along the way, I learned a lot about how to figure out exactly like what the specific movements of our simulation is. So the first thing that we did was to figure out what movements will actually cause a change in the flock. So we devised about 4 rudimentary gestures. So let me see. The first gesture was a simple translation. So we used either one hand or both hands. And all we did was move the hand from side to side in all directions. And this allowed the flock to move as a unit based on our gestures. That was the first movement, so translation. The second movement was scaling. So we could move our hands apart from each other. And since we have the position data of the Kinects, we can calculate the distance between the two hands, and we can use that to change the spread of the drone, the flock itself. That's the second one. The third one was the rotation. So if we move our hands in a direction that's, in an angle that's different, we can rotate our flock. So those were the main movements. So I used Kinect. So in the past, like we used to go to the studio and take recordings of our Kinect of the body movements in order to generate data for testing and stuff. So I found this neat little program online. It's called the Kinect OSC V2 package. So one of the problems we had was we were working with a V1 Kinect, and we needed to upgrade that to a V2. So in order to solve that system, we used a Kinect V2 OSC package, and that was very interesting because we only needed 2 laptops and a Kinect instrument to record data, and that made our data analysis much more quick. That was one thing that happened. And then we use a transmission protocol known as UDP. So UDP stands for User Datagram Protocol. So this protocol has been used in the past for real-time simulations. And one reason why this is a good design choice for this project was we wanted real-time simulation. So, you have a question? Oh, 1 minute. Okay, sure. Yeah, that's awesome. Okay. But yeah, so UDP was used because we wanted real-time simulation. So comparing it to TCP/IP, we did not want, we did not mind if some frames were missed because the frame rate was very quick. So we wanted quick reactions for like the signals that were being sent. The questions that we wanted to answer through this project was, how can a music conductor use his gestures to create flock movements? And is it possible that these flock movements could be put on a big screen and be used to enhance concert performance? And these are still questions that that I'm sure many of you might probably be interested in thinking about for the future. This is by no means complete, and there's a lot of things that can be done. Thank you. Sure. Yeah.
So you used UDP, right?
Yeah.
So when you did get packet loss, did you just ignore the lost packets, or
yeah,
did you try and interpolate, or?
No, so just for like, because this is still like, we were still like in the initial phases, and we just wanted to make sure that the framework actually worked. So for now, we've actually just ignored the packets that we've missed. But yeah, of course, that's the next step to like making it more robust.
Could you say something about why? I mean, you could imagine using gestures like this to control a single quadrotor. So why were you thinking about doing it as a flock of particles? I mean, yeah.
Okay, so yeah, if I want to control a single quadcopter, it's actually pretty straightforward. I could use my hand position data and connect it directly to Unity. But the idea of creating a flock of objects that can act as individual agents, so